Okay, thank you very much. So, grid layout got to be a thing. We're sort of over a year into having grid layout in our browsers. And I think most people think it's pretty cool. And some people have even shipped some sites using it. It's not just me. And we actually already have a first public working draft of grid level 2 of the CSS working group. That's going to concentrate on the subgrid feature. And I've kind of given up, I'm afraid, answering all of the questions that I get about grid. I get an awful lot of email, and if I were to answer all of my email and all the questions that were sent, I'd never actually do any work. But looking at those questions, and what I've tried to do when people send me all this stuff, is to have a look and see, well, what are the real problems people are having? What are the questions? Where do they originate from? And in looking at that, I think there are a couple of problems with grid, and that's where a lot of these sort of issues originate. And the first of those is sizing. Everyone seems very confused about how big everything is. And they're very confused about how grid and flexbox distribute space. And I think the reason that is confusing is that we've spent years and years using layout methods where the size of our things is quite straightforward. We can use length units, so pixels or ems or what have you. And we understand what that actually means when that's on the screen. And we've also sized things using percentages, using sort of fairly straightforward maths to find out the dimensions for our flexible grids, as was described in Ethan's article on fluid grids. Now, those percentages don't look very pretty in our style sheets, but we understand them. You know, we know that as long as we don't get more than 100%, no bad things are going to happen. And then we got things like box sizing, border box, and that made everything much more straightforward because we weren't having to account for the size of the padding and the margin and so on. We've got all these layout frameworks, and they do the math for us, so we don't have to be calculating those percentages. And then we got flexbox and grid layout, and they started to behave a bit strangely in terms of how big things are. Things in our layout become bigger or smaller than we expected they would. And as a result of this, people started to create flexbox-based grids using percentages, just like their kind of floated forebears. And with grid, the first thing that most people seem to do is to fall back to percentages, to size the tracks using percentages, because they kind of know that's going to work. And they keep away from this sort of slightly mysterious FR unit, which doesn't quite do exactly what you expect. And it's because of this, I kind of declared this year as the year of how big is that box. Because I want people to understand how things are sized on the web, because it really opens up all of this stuff that we're dealing with and allows us to use flexbox and grid far better. Let's have a look at how grid layout works out its sizing, and then we can learn a few interesting things along the way. Now, to learn about sizing, we need to scroll down the specification. Now, if you keep on scrolling down the specification for a very, very long time, you'll find the bits that we web developers usually say, that's for browser engineers, I'm not going to look at that, that's a little bit scary, here be dragons. But it's in there that we enter the rabbit hole, because that's where the algorithm is that tells us how big things are. And it's kind of used to have a look. And I'm not going to explain the entire algorithm to you today. There's only a few of us who are really interested in that stuff. But I'm going to pinpoint a few things in there which I think are pretty useful. Because the spec says that each track has specified minimum and maximum sizing functions, and they might be the same. So what's a sizing function? We've got these sort of three types of sizing. We've got fixed sizing, we've got intrinsic sizing, and we've got flexible sizing. Now, fixed sizing is the thing that we're all used to. So sizing stuff with a length unit, so that might be pixels or ems, and percentages also fall into this, because percentages can be easily resolved, in most cases, to a sort of fixed size. We can work out what that is a percentage of, and we know how big it is. So we're treating them the same, really, as length units. And then we have this word intrinsic sizing. Now you're probably familiar with some intrinsic sizing because you're familiar with auto. But we've also got some specific intrinsic sizing keywords: min content, max content, and fit content. Now auto, when you use it for track sizing in a grid, so you're in grid layout, you're using auto for your track, that can be thought of as big enough to fit the content in most cases. And we'll have a little look at really what auto means in a bit more depth. But if you create a grid with auto-sized rows, for example, and you put some content into that row, then the row gets taller to fit the content. So it kind of expands, and that's auto-sizing in action there. Something that is useful as we look at auto-sizing is that if you use auto for track sizing, it will stretch by default, unlike all the other sizing functions. And where you'll notice this is with column tracks. And here's one of the questions I get. Why is this column track getting bigger? If I use auto for the final column track, it stretches to take up all the extra space in the inline direction. Although the actual size created by that track, so if we say justify content start on that track so that it doesn't stretch out, you can see that it doesn't actually need that much space. You're overriding the stretching behavior with justify content there. So sometimes auto seems a bit mysterious when it does this stretching. As long as you know that it's going to stretch, you can change that with the alignment properties. If you remember that the default for justify content is stretch, auto tracks will stretch. You don't want them to stretch, set justify content start on the container or target the individual item with justify item start. So that's auto. And then we've got the new sizing keywords that I mentioned. Now they're not just for grid layout. You're going to be able to use these sizing keywords in other contexts, for instance, just to size a string, but they're well implemented in any browser that has implemented grid layout for track sizing. So let's have a look. We've got this keyword min content. So you use that as a size, and we can use that for track sizing. And what happens with min content is the track will get as small as it possibly can. It'll take any soft wrapping opportunities that it's got. So in most cases, it's going to become as wide as the longest word. So I've got an example here. We've got 3 column tracks. They're all sized using min content. So the track content is now impacting the track sizing. Rather than us saying, well, this is the size of my track, the content's got to fit into it. So if you've got anything in the track that has a width of some sort or contains something with a fixed width, well, that's going to make the size of the track. And if we've got text in there, it's going to wrap essentially to as wide as the longest word there. Then we've got the opposite. We've got max content. Now, as you might imagine, if min content makes your text as small as possible, max content is going to let it spread out as wide as it can. So it'll not do any soft wrapping at all. It'll just get, if you've got a great long sentence, it's just going to keep on going. And the track will get as big as it possibly can. Now, this may well cause overflows because we're not doing any soft wrapping at all. So that's the tracks all sized with max content. So once again, the browser looks at the content to work out the track sizes. The first and second tracks here are stretching out the maximum size of content in that track. Now, my second column track has an item there with a width in it. And so the width on that item is constrained, but the track it's in is defined by the longer item above. So it's stretching out in order to be at max content. And then we have this fit content keyword, which is really interesting because in grid layout, we can use fit content. And what it does is it says, well, I'm going to be like max content. I'm going to get as big as I possibly can, but then you pass in a value and say, but don't get any bigger than that. So I've got 3 tracks here. The first 2 are clamped at 10M. We've got one at 15 CH, which is roughly 15 characters. So we've got these 3 tracks. And then our first track, it can spread out until it gets to that maximum value, and then it starts doing its soft wrapping. The second track acts like max content. It's only got a single character in there, so it only gets big enough for that single character. And then the third track, we've got an image in there, which will, if you've got max with 100% on the image, will get sized down and fit into the track. So remember those concepts, because we'll be coming back to them. But before that, let's look at that FR unit. Now we only get the FR unit in grid layout. It was designed for grid layout. And it's a flex unit. So this is the flexible length. It's the sort of inbuilt CSS way to do those fluid grids that we've been doing with percentages. It defines a portion of the space in the grid container. So if I define 3 tracks, 1 of 2FR and 2 of 1FR, the available space is going to be divided into 4 and shared out, 2 parts to track 1 and 1 part each to track 2 and 3. So we'll get something like this, as long as all the content in the tracks is exactly the same. And every time we sort of show demos like this, and they're everywhere, because this is everyone's first grid layout demo, people think, oh, well, that means all the space in the grid container is shared out equally between these items. And it's not quite, as we'll see. We can go back to those minimum and maximum sizing functions, because now we've kind of worked out all of the different ways that we can size tracks. So we can now work out how grid is working out what the minimum and the maximum size for our tracks might be. And we've got another sort of piece of functionality in grid that actually sort of exposes that to us directly. And that's the min-max function. So this part of the grid layout spec, it lets us have an easy way to say, well, I've got a minimum and a maximum sizing. So we can actually impact that ourselves. Let's have a look. So I'm now using min-max for my track sizing. So the minimum size of that track is the value used for the first value passed to min-max. So it's not going to get smaller than that. So in this case, we've got 100 pixels, out of 10M. That's going to be our minimum size. If we step away from min-max and used FR units or fit content, then it's just like we'd use min-max, essentially. The minimum size of that track is auto. Otherwise, you're using a length or a percentage, in which case the minimum sizing function is that length or that percentage. You've said, I want this track to be 100 pixels. Well, that's its minimum size, because you've said that's what the size should be. So then if we use min-max, and we look at the maximum size of the track, well, that's the second value you've passed to min-max, because you've decided that you want to say, I've got a minimum and a maximum. Now, if you use auto or fit content, then the maximum will be treated at max content unless you've passed a value to fit content, in which case that becomes the max. And those pixel size tracks, well, the max is the same. This is why it says the minimum and maximum sizing function may be the same, because you might have said, I want that track 100 pixels. Well, the minimum's 100 pixels, and so is the maximum. So that's kind of what's going on under the hood. Grid's working out what the minimum and maximum is for any track. So we can now work out kind of how big the grid is. And we start with the simplest case. We've created a fixed size for our tracks. The minimum and the maximum size is exactly the same. And that would be the case if you used a length or a percentage, which will then be resolved as a length. So in this example, everything's a fixed size. Nothing's intrinsically sized, nothing's using an FR unit. If you put something too big in there, it's going to overflow because it can't grow for it. So this is our very simple grid, a very fixed size grid, not using anything special about grid layout. And this example is a bit more like what most people are going to do. And this is about as close as we can get without grid layout. So what we're doing here is we've set our column sizes fixed, but we're allowing the rows to expand. We're saying the rows are auto. They can just get as big as they need to for any content. As I say, that's pretty much where things stop prior to grid. You can kind of control column sizes when using floats, but you can't do a lot about how tall things are. You just put the content in and it just expands down. If I'm in grid layout, I've got all this cool new stuff, and most likely I'm going to want to use a flexible sizing function. I'm going to use that FR unit to size the tracks and allow the content to define the height. So the browser's now sort of working out how much space we've got and sharing it out between our tracks, and they're going to be flexible if we've got more or less space in the container. And then however much space they need for the content to display in the tracks, well, because they're auto, that's just going to work out. And here's where it gets interesting with the FR unit. I mentioned earlier that having a set of 1FR tracks, for example, doesn't quite mean those tracks are going to be equal sized. We're not going to just take all of the space in the grid container and share it out equally. Because if the track is sized using FR units, it's as if we've used a sizing function with, say, min-max auto 1FR. The minimum size of that track is auto. So grid needs to give the tracks an auto minimum, work out how much space that track kind of needs, and then share out the rest of the space in proportion. So you might have 3 1FR tracks, but them not be equal width at all. For instance, if you've added a very long word or something that can't break into one of those tracks, the auto minimum has to be larger for that track because it needs to display that very long word. So here we've got 3 1FR tracks, but track 1 is much bigger than all the others, and then the space has been distributed to the other 2. Which leads us to another really useful bit of knowledge. If you actually want 3 equal size tracks in that example, then you need to make the minimum sizing function 0 by explicitly using min-max. So you say min-max 0, that's my minimum size. Nothing's really then got any size. The maximum is 1FR, share out all the space between the tracks that we've made. Which obviously might cause overflows, because the reason that grid has made that track bigger is to fit in the big thing that you've got there. And that's why the default's auto, because if you've got space, we kind of assume that you'd rather things didn't overlap each other. So that's why the default is auto rather than 0. It allows the bigger thing to be displayed rather than hidden. We do tend to try in CSS not to hide your content. That's sort of a rule to live by, as it were. And so we don't make things disappear because you can kind of see, oh, well, things are the wrong size now, how do I deal with that? Rather than stuff just overflowing and looking weird. But maybe that's what you want. Maybe you want to have that and then control the overflows. Of course, if you have your item then spanning 2 tracks, the problem kind of goes away because it's got enough space in the 2 tracks and then the rest of the space is shared out. So I've gone back to my 1FR tracks here, and then the item containing the long word is spanning over. So it's kind of where you want to control things versus what grid is doing. You make those decisions about how you size things and to take advantage of what grid can do and the outcome that you want for your layout. And then we kind of need to talk about everyone's favourite trick, because I think everyone speaking about grid on stage does this and shows this little bit of code. And knowing a bit about sizing allows you to really understand how this works. So this is our ability to add as many columns as will fit into the grid container by using repeat notation with the autofill or autofit keywords. So hopefully this makes a little bit more sense once you've figured out a bit about sizing. Because we're asking grid layout to fill as many column tracks as will fit into the container with a minimum size of 200 pixels. We don't want those tracks smaller than 200 pixels. So grid's going to go through, it's going to add our 200 pixel tracks, and then we get a bit on the end. I don't know, maybe there's 100 pixels left over at the end. Well, that's not enough to put in another 200 pixel track. The maximum is 1FR, so that space is just distributed back over all of the tracks. So they become a bit bigger than 200 pixels. So that's what's happening. It's that available space is being shared out amongst our tracks. So we can get these nice arrangements of boxes. And they're kind of responsive, and they, as you can see here, we've got gaps in the arrangement as grid is just working out where to put things using auto placement. And of course, if we want to, we can set auto flow to dense, at which point grid will backfill the gaps. So we're able to create grids with a flexible number of flexible columns and pack it densely, and the browser just does that for us with a few lines of CSS, which is absolutely magic. Now, there's obviously, with this kind of dense packing, we're taking things out of source order, and so you should be very, very careful not to do that with anything that has a logical order, because the browser will follow the order of the document and not your visual order as it is, as someone say, tabbing around that content. You should be very careful with some of the stuff we can do with grid. But I think there's so many creative possibilities here. And once we get away from always thinking that a grid has to be a bootstrap-like 12-column grid, we can play around with our grids, we can play around with sizing, we can play around with the fact that grid understands how big things in our content are and distributes the rest of the space. I think there's loads of really neat things that we haven't really started to look at yet. We're still really in the phase of trying to reproduce the layouts that came before using grid layout, which is a kind of a good way to learn. It's how I learned. But I'm really excited to see where people start to take this stuff as they kind of really sort of pick at some of the finer points. And moving away from sizing, there's something else that is really important about grid layout. It doesn't matter which way up your grid is. Let's have a look what I mean. When I started talking about grid layout, my very original sort of big CSS grid presentation I was doing long before the spec ended up in browsers, I would go through all of the properties for grid layout and explain them with demos. And I'd explain that you could define all 4 lines of a grid area with the grid area property, and that the order of the lines is grid row start, grid column start, grid row end, grid column end, which, if you think about it and you draw it on a bit of paper, you'll realize is the opposite of how we declare everything else in CSS, for instance, margin and padding. And people are like, what? Are the CSS working group trying to make our lives just difficult? Is this sort of some curve thrown at web developers? And it's not. The reason this is so is because these values have moved away from the underlying assumption that content on the web maps to the physical dimensions of the screen. Content on the web is typically assumed that everybody is writing in English, really, or certainly in a left to right, top to bottom language. So all of our older CSS properties kind of assume that. And the newer CSS doesn't assume that. The newer CSS has realized there are more languages in the world and they don't always flow in the same way. So they've been specified that if we change the writing mode of our document, say to a vertical one, the position of a block always stays the same, and we're specifying the start and the end values. So if we've got a writing system with a horizontal writing mode, so horizontal, that would mean whether the text is left to right like English or right to left like Arabic, the inline dimension is along the rows of text. So that's the inline direction, the way that a sentence runs. And so the block dimension then runs down the page top to bottom. So when we talk about blocks in CSS, we might have a paragraph block. Well, those blocks run down. So that's the block dimension, is following those blocks down the page. And you'll hear a lot more about the inline and block axes with newer CSS. So here we're working a document with a vertical writing mode, so the inline direction here is top to bottom, and the block dimension runs horizontally. So if we're in grid layout, if we're in a horizontal writing mode, the inline axis is running horizontally and the block axis vertically. Now if we look at flex layout, just step away from grid for a second, flex layout is actually a bit more complicated in this regard because we can obviously change the flex direction independent of the writing mode that we're in. So you can have a flex direction of row or column. So if you're working in Flexbox, it makes a lot more sense to refer to the main axis, which is the one which follows your flex direction, and the cross axis, which is the one that runs across whatever your flex direction is. I actually think that a lot of the alignment properties and so on are far easier to understand in grid layout because you've always got both axes going on and you don't have this switching of the axis that you do in Flexbox. So when we go out to grid, when we're setting the start and end lines of a grid area, all we know is that we've got start and end lines. We don't know if we've got top, right, bottom or left because we don't know which way round the grid actually is. So I've got my 3-column 2-row grid and I want a grid area in a horizontal left to right writing mode to cover the first 2 columns and the first 2 row tracks, so a bit like that. So we can see how we set the column and row start and end, and how in the grid area property we're setting both starts, then both ends. And if we were in a language like Arabic, so we were running right to left, it looks exactly the same, but start is now on the right, because that's the direction in which that language runs. And if we end up working with a writing mode that has our content running vertically, we have this. The grid essentially works in exactly the same way, no matter which way up it is. Line-based positioning works the same way, whichever way around you've got your grid. And you'll find the Firefox Grid Inspector incredibly useful if you start turning your grid on its side. These are screenshots from Firefox of the example I was demonstrating. Firefox DevTools, if you open that up, it will add a grid outline, it'll add your line numbers, so you can see exactly how the positioning works. Really, really useful. If you don't normally use Firefox, I would certainly get it out when you're working with grid layouts, because the tools that they're creating are fantastic. I think Firefox is doing a really, really good job at creating design developer tools. Whereas Chrome have gone down the line of sort of performance and so on, you find that Firefox have got some really great tools for design and for working with layout. So do check that out if you've not looked at the Firefox DevTools. It's really worth doing. So once we know a bit about writing modes and why we've got this sort of strange thing going on where we're not looking at the top and left anymore like we were, say, with absolute positioning, then that's going to help us understand alignment a lot more. Because alignment also considers these writing modes in our document. And so we need to, again, think about start and end in each dimension. And we've got a couple of different things that we might want to align in a grid layout. We're going to want to align the tracks themselves, assuming you've got some extra space in your grid container to share out. And we want to align the items, so the sort of content inside any grid area. We might want to move that around the grid area. And all of this is defined in the box alignment specification rather than the grid layout spec. And box alignment pretty much took those nice alignment properties that made Flexbox so cool, put them into another spec, which means that they can be used all over CSS. And so where they're now implemented is in grid. So you'll find if you understand alignment in Flexbox, it works in a very similar way in grid layout. Let's have a look at aligning tracks. So to align tracks, we need some extra space in the grid container. So here we've got our grid items, our tracks are all up in the corner because we've got this extra space. They're fixed size tracks. The grid container is bigger. There's extra space. And so we can play with that space. By default, the tracks are aligned to start, which is why they're up, because I'm in English, which is why they're up in the top left there. So there's our start. And then we're going to deal with the content properties which deal with free space. So what do we want to do with our leftover space? Now here's something that confuses people. Do we use align content or do we use justify content? Align properties always work in the block dimension. So they always work in the direction that the blocks run down the page. So if you're using align anything, you're working on the block dimension. If you're using justify anything, you're using the inline dimension. So if I want all my tracks to move to the end of the grid in the inline direction, so that's along the rows, I can use justify content end. I'm justifying to the end line of the grid. So what that means is the free space is placed before the tracks. If I want them in the center, in the block direction, align content center. So our free space in the block direction, that's all placed above and below the tracks. So again, what we're doing here is distributing space. We decide where we want the tracks to be, and then that's what happens with the space around them. Now you've used Flexbox, I'm sure you've used space between, space around, or space evenly. We can use those in grid layout as well. We can set justify content and align content to one of those space distribution keywords. And so then you end up with everything spread out like this. So align content space between, I've got justify content space around. And there your free space is divided up and placed between or on either side of the items. Now you can see that's made the gaps quite a bit bigger. The gaps have grown because we've shared out space. We've added space essentially to the gaps. And if you've got any item crossing the gap, that is going to get bigger too, because the item is over that gap. It's going to absorb some extra space. So here I've got a large item which is spanning over 2 columns and 2 rows. So there the items are aligned to start. And with space around in the block dimension and space between inline, that block is getting a lot bigger because essentially the gap is through the middle of it and the gap's got bigger, so that block has got larger. And all of this works in exactly the same way if you use a different writing mode. Start in the inline direction is always where your sentence starts. Start in the block dimension is at the top of where your blocks start going down the page or across the page if you're in a different writing mode. So, something like this. If you look at the code, all the code for this is online, but if you look in the code, you're going to see the use of block size instead of height and inline size instead of width. Now, those are new logical properties, which I don't have a lot of time to explain now, but we're actually moving all of CSS away from this thinking about width and height and top and bottom and creating new logical properties and values that allow us to create designs that basically do just work whichever way up they are. I've written a whole bunch of stuff. There's an article on Smashing Magazine where I went through a lot of these only work currently in Firefox, the logical properties and values. So you can go through, and there's some examples there. If you use Firefox, you'll be able to play around with the examples and see how they work. It's kind of interesting, and I think it's interesting that this is the way that the web is going and that we're starting to think about these different writing modes, which obviously you can use if you're creating a document in that writing mode, but there's loads of creative possibilities for writing modes too, and being able to have text on its side and written in a different way. We've looked at aligning the tracks, and that's really about space distribution as it is with Flexbox. But then we've created a grid, and we've got items in grid areas, but we might not just want them to stretch all over the area. We might want to move them around inside the area that we've defined. So then we're going to deal with the items. So you've got align items and align self to deal with the block dimension, and justify items, justify self, which deals with the inline. And the default for align items and justify items is stretch, which is why when you do your sort of very basic grid demo of 3 columns, everything fills the column and looks nice and neat. The exclusion to that is that anything with an intrinsic aspect ratio, for example, an image, will be aligned start by default. This means that we don't stretch your images and make them look untidy by default. So if you've just got regular content, then it will stretch. If it's an image, it will sort of sit up at the start so that it doesn't get all stretched and look a mess. And so we can do justify items on the inline axis and bump all our items over. And we can do align items on the block axis. These things are all staying in the area we've defined. They're just moving around inside it. Once again, Firefox Grid Inspector, really useful. You can see where your grid area, your grid cell or your area is, and see that it stays the same size. We're just bumping the stuff around that's inside it, moving the alignment of it. And align items and justify items, what it's doing is it's setting basically as a group the align and justify self properties on individual items. So you can target a single item and just change its alignment. Where does it go inside its space? For instance, here I've decided I do want that image to stretch rather than align to start. So we can set it with align self and justify self to stretch, leaving the other items as I've specified. And now that one is stretching where the others have been aligned differently. That's pretty neat. We've got a whole lot of new functionality sort of deeper into the grid spec. Once we get away from those very basic examples, we've got all these interesting new sizing possibilities. We've got these interesting new alignment features tied together with the fact that grid properly respects writing modes. So you can use that for languages in those writing modes and also for creative possibilities. And I hope that helps you understand the grid a bit more. But I kind of wanted to finish with the third thing that I am saying an awful lot this year. When I demo all of this stuff, typically someone will say something which is essentially, can I have a magic polyfill which will fix grid in older browsers? And I'm really sorry, but the answer is no. No, you can't. And this is why. Because we've got grid support in all of these browsers. We've got really great grid support in modern browsers. But what Can I Use is pretty bad at showing is kind of the unupgradables, the people who are stuck on old browsers because their device doesn't support an upgrade. Now, yes, we do have people in companies who refuse to upgrade from old versions of IE, but other than those people, increasingly, the browsers that don't have grid now are mobile browsers. And increasingly, those browsers they're not our mobile devices and our browsers. They're browsers running in non-Western countries, usually running on slower, older hardware and on expensive data plans. The polyfill grid would mean a lot of very expensive JavaScript. If you've ever tried to do equal heights and so on using JavaScript on a floated layout, you will know that it gets very janky and unpleasant if you've got many items. So to polyfill grid, you would essentially be forcing a bunch of JavaScript, a bunch of very slow and janky JavaScript, onto the slowest, oldest devices and the people who have the expensive data. Which just seems a terrible, terrible idea. Because the things that grid is doing performs very, very well, and it doesn't involve a lot of CSS. And so what doesn't perform well is JavaScript trying to do what grid is doing. And that's not an anti-JavaScript thing, that's just a fact. Doing layout in JavaScript is slow. And because grid is so lightweight in terms of the amount of CSS that you need to be writing, and not needing wrapper elements and so on, grid can help you to create a better experience, even if the person looking at your site doesn't support grid. This grid layout here, this is all the CSS that we need for a 12-column flexible layout with all boxes in a row as tall as each other. It's very, very little code. So you can afford to have a few lines of code enhancing your layout. If that's downloaded by the browser that doesn't support grid, this is not a problem. We don't worry about that. So it allows us to start to create fallback layouts and then enhance them with grid. And we can do that far more easier these days than we used to. Because new CSS, it was kind of written by the same people, so it knows about the old CSS. We know this stuff exists. So it lets us build these simple layouts and then just override by using newer CSS. And just as you build a layout tailored to small screen devices by using media queries, you can build a layout tailored to your non-grid supporting browsers by bringing in feature queries. It's the same thing. By using these two things, we're able to provide a good experience to users no matter whether they're accessing content on a low-powered phone or an iPhone 10, a tiny laptop, or a top-of-the-line Mac or Windows machine. We see these things as the same, media queries and feature queries. What features does this device have? What features does this browser have? If we consider what happens if our user has pretty much nothing, we can structure our content well. If that content just loads in block layout, one thing after another, on a very limited mobile device, that is probably exactly what you want to do. Just show the content, let them read the content, they can scroll, it's great. That's much better than a horrible janky experience as all this JavaScript loads in trying to make something different. Now perhaps that little device is a higher end device and it does have CSS grid. So maybe I'll start to tweak that layout. In this case, I'm just going to add a little header detail. This is one of my favorite tricks to use some generated content to add a little border. And so we get something, if you've got a grid supporting browser, you get that little header detail. Now with the border, you probably won't get that appearing in a non-grid supporting browser, but say you wanted to put a little icon either side of the header, well, you wouldn't want that generated content appearing in a non-grid supporting browser because it would appear somewhere strange. So there, we might use a feature query. So I'm saying @support display grid. And I'm doing my grid stuff inside that feature query so it can't kind of leak out and be displayed in a strange place if the browser doesn't support grid. Now, I have got some grid CSS there in the header H1, but it doesn't matter because that's the way CSS works. If a non-grid supporting browser comes across some grid CSS, it's like, I don't know what this is, and it just ignores it. The only things you need to worry about wrapping in feature queries are the things that would be interpreted in both contexts, the thing that doesn't support grid and the thing that does. So we've got mobile with no grid, mobile with grid. Oh, and the image there, that's nothing fancy. It's just a square image I turned into a circle using border radius. Pretty much everything supports border radius. and which does point out that don't forget that older CSS still exists. I have a lot of questions from people who are essentially trying to re-implement floats in grid layout. If you need a float, I would suggest using a float. It's still valid. It still exists for what it's designed for. To get a bit wider, I'd like to do something nice with that little image. So I'm going to float it left, and I'm going to cause the text to curve around it. I'm going to use shape outside margin box. That's part of the CSS shape specification. And so we get this. Now, browsers that don't support CSS shapes are like, well, what is this? And they just ignore it. So they'll get it squared off, because we can only use shapes to apply them to a float. There's a nice bit of backwards compatibility built right in there. You get a floated item, and you either get the nice curved text, or you get the squared off text. This screenshot was actually in Firefox, who don't support CSS shapes. The next version of Firefox will support CSS shapes, so suddenly those users would see the curved effect. Firefox are also working on a really cool CSS shapes dev tool, which is worth checking out. That's going to be shipped along with the shape support. As we start to get wider, and you see now my text's getting a bit long, so I'd like to break that into 2 columns. I'm co-editor of the multiple column layout spec, which means that I absolutely have to have a bit of multicol in every presentation, so here it is. But the nice thing with multicol is it's really well supported. So we'll say column width 15em, we'll only get 2 columns if we've got enough space to make 2 columns. But the problem with multicol is that if someone's on a very short screen, say a phone in landscape mode, what you don't want is people having to scroll up and down to read your columns. That is not a very good web experience. So I might use a vertical media query to check for height. And we'll only get 2 columns if I've got a decent amount of height. So that's quite a useful tip working with multicol. You can say, I know that I'm going to have so much text here, and I don't want it to go into columns if I haven't got enough height for those columns to be displayed in all red on one screen. So we get this. The columns kick in once there's room for 2 of them, so we don't need to add a width media query, and the height media query stops them showing on small screens. So to finish off the article component, I'd like to do something with the cards at the bottom of the layout. Now we've got enough room for them to display more than 1 in a row. And I'd like to arrange those boxes into a grid. I'm going to set the resources there to max width 60em, and I'm using that grid autofill functionality to fill the container with columns which are a minimum of 15em, which means we only get more than 1 column over 15em. If we've got enough room for 2 15em columns plus the gutter, we'll get 2, and we'll max out at 3. And if we've only got 2, they'll line up with a multicol above, because grid gap is 1em, which is the default column gap for multicol. Now this is only going to work for people with grid, so then we need to make our decision for non-grid browsers. Now you could just leave it alone. That's a valid choice. If you look at your stats and say, well, we've hardly got any non-grid browsers, and particularly if a lot of those are mobile devices that are going to have it in 1 column anyway, you could just let it be. Let it just display in block layout, that's fine. Or you could choose some other layout method, maybe display inline block. So we can use that as a fallback. We set it to display inline block, and then we use feature queries to override the width that we've set on it. So using inline block, that means our cards still run left to right, which might matter to you. You might need to keep things in that order. An alternative, if you've got cards that could display by column, you could use multicol as a fallback there. Multicol is quite a useful fallback for a lot of grid type layouts. So we'd use multicol. And those multicol properties are going to be ignored the minute it becomes a grid item. So it doesn't matter. You can have the column width property, and it will just be ignored once it becomes a grid layout. And so that makes a much neater layout. You don't get the gaps that you do with inline block, but you are running via columns. And the reason I'm showing you this isn't just to show you that you can do fallbacks with grid layout. It's to show you that it's pretty straightforward to create a good experience for all users. Think of this stuff component by component and make each component good no matter what context the user is in. We can achieve an awful lot with very little CSS, for small to large screens, from browsers without grid to browsers with grid, using fairly trivial amounts of code, and without needing to ask people on limited devices to download a massive amount of JavaScript, which may well also cause a janky experience on a slow device. We talk a lot about performance. But really, before we start to think, does this thing perform well, you first need to think, do I even need to be using it at all? And we don't want to be doing things that are going to cause a suboptimal experience for that's the very users we're saying we're trying to help by polyfilling grid, are the people who actually get the poor experience when we try and polyfill grid. You need to reframe the discussions you're having around browser and device support, even more now. It should never be, how do we make this look the same in all browsers? It should be, how do we get a good experience for all browsers? Don't worry about making people's experience look the same. Worry about making it equally good. Because we really do have the tools to do that. We're in a far better position now to provide great experiences to everyone. And don't let lack of support for grid in certain browsers hold you back from realizing really great designs and providing great experiences for the majority of people viewing your sites. But likewise, don't let all the new shiny mean you forget about those people who don't yet have it. It's become a bit of a trite thing to say from conference stages, but I really do believe that the web is for everyone. I would never have got into doing this had it not been sort of a very, very low barrier entry to be online, to use the web and to build things. So, I'm not here to build shiny toys for rich people. And, even though this medium has been used for some not great things recently, I still believe that we have a lot of power in our hands as developers to change lives, to make things that, get content out to people all over the world and to share our experiences together. And that's really important to me. So let's go out there and do that and enjoy the rest of today. And my slides are online there. Thank you very much for listening.